Assalamu alaikum. Can you see the slide?
Sir, yes, sir.
So
Yes.
today's lesson. Today's lesson will be a short one, 35 minutes. That's some of my commitments. And then after 35 minutes, you will have 5 minutes break. That means at 9:40, you will join the class of Dr. Farooq. Okay. Then again, we will have 35 minutes class. We will cover up if anything is left in other classes. So in last class, actually, I was talking about engineering materials. We defined engineering materials, and then we discussed about the various types of engineering materials. And especially, I've taken one example of Burj Al Khalifa, where we saw that in Burj Al Khalifa, they use huge amount of concrete, which is one of the engineering material. That actually, concrete is a composite material, and the concrete itself is made of various types of material like sand, cement, water, then stone chips or brick chips. That is one type. Then in Burj Khalifa, there was, in case of the facade, that they used aluminum, silicon, and glass. So actually, these are the 5 or 6 types of aggregates, 5 or 6 types of engineering materials that were used. So today we'll be concentrating basically on aggregates, okay? And first of all, let us see that actually in case of concrete, actually we know what concrete is, okay? So in case of concrete, actually the main constituent materials are cement, then air, and then aggregate. The cement, it makes 25 to 35%. Okay, of the total volume, of which actually the percentage of cement varies from 7% to 15%, and percentage of water varies from 14% to 10%. And then 8% are air. And actually, these airs remain actually between the aggregates, also within the aggregates. And the majority of the part is aggregate itself, the remaining portion. So other than cement and air and some bit of water, okay, the remaining part is aggregate. So as you can see on this pie chart, if you see that gravel, which is one type of aggregate, okay, actually we crush gravel and then we get stone chips. Brick is also one type of aggregate, okay. Instead of stone chips, earlier in our country, still, in some places we use brick, but because of its less durability and because of its less strength, nowadays actually in all the projects we use stone chips because these are stronger than brick and more durable. So those stone chips, actually we get it after crushing the large stones. Okay, they are crushed, the crushing machine, or the gravels. Okay, so they are crushed, and that's how we get stone chips. So the stone chips, that means the gravel, that constitutes the 40% of the total volume of concrete. Then 5% is air, then 10% is cement, then 20% is maybe water, and the rest 25% is sand. So sand is a fine aggregate, and stone chips or brick that we use, that the coarse aggregates, which makes almost 40%, and that makes those are the ingredients of concrete. Now, what is an aggregate? So aggregates, if we define aggregates, aggregates are naturally occurring inert granular materials such as stone, gravel, or crushed stone. What is inert? Inert means the materials which remains inactive in case of chemical reaction. So according to the definition, aggregates are not supposed to take part in chemical reaction when they are mixed with sand or when they are mixed with cement. That is the official definition of aggregate. But later on, when we shift to other classes, then we'll see that some of the stones, actually, they're not inert. Actually, they do make some chemical reactions. Now, what is the function of aggregates in the concrete? In the concrete, the aggregate has got three functions. First of all, the stone chips or the brick chips that we use in the concrete to provide a mass of particles. Okay, so that means as it occupies the major volume. So due to this mass, okay, so it can resist the load which is coming onto the concrete. Also, it shows better durability. So you can make a plain cement concrete, but you will not have any stone chips or brick chips. Now, if you make concrete with cement paste only, and if you make concrete with stone chips only, then you will find that concrete made with stones chips will have a better durability and will better resist the load which comes up to onto it. Second action is that it is a relatively cheap filler for the cementing material. Okay, because in case of concrete, actually the stones that react with the cement, and then if concrete is a matrix, okay, then it is filled up with cement, then stones, other things. So it is found that stone is relatively cheaper. You can use other materials also instead of stone, but those will not be cheaper. Third one is to reduce the volume changes which comes due to the setting and hardening process and from moisture changes during drying. Actually, when you mix cement, water, and then stone chips, okay, and when concrete mixture is made, so at initial stages, what happens? The first stage is setting of concrete. That means concrete remains in a semi-liquid state. So it changes its state from the semi-liquid state to a semi-solid state and solid state. So there is change of state, that is called setting. And in the setting process, actually, concrete does not gain any strength. And then immediately after that, okay, the hardening process starts. Hardening is the phase when the concrete gains strength. So actually, due to this setting and due to this hardening process, actually the volume changes takes place. So if we use aggregates, that reduces the volume changes. Instead of aggregates, if you use only cement paste, so you will observe huge volume changes. At the same time, when the concrete gets hardened, okay, so that means the moistures which are within the concrete, so that will be changed, okay, and gradually the moisture will evaporate, the moisture will be absorbed, and when due to that means when the concrete will be drying, there will be change in moisture. So that change in moisture, actually the stones actually it reduces, okay, the volume changes, which results from the moisture changes, which causes to drying the concrete. Now, characteristics of quality concrete. Okay, so these are very easily understandable issues. Concrete should be clean and durable. Okay, and it should be free from organic impurities and dust. Why? Because if the aggregate, this aggregate is actually, if it has got dust, then it will not make a bond with the cement. Well, what happens? The concrete makes bond with cement. The cement actually act as a coating, okay, surround the aggregate. So if the aggregate is surrounded by impurities or dust, then the coating will not take place. As a result, the bonding between the cement and the aggregate will not take place. And as a result, the strength of the concrete will be poor due to the poor bonding. Then the requirement of good aggregates, it should be chemically inactive. We said in the definition that aggregate should be inert so that it does not take part in the chemical reactions. It should be strong enough. It should be hard enough. There's a difference between strong and hard, and then it should be durable. Okay, that means it should long last. Then aggregate should have rough surface. Aggregate surface may be rough, maybe smooth, but it is preferable that aggregate should have rough surface. Why aggregate should have rough surface? We'll be learning that. Then shape of the aggregate matters. Some of the aggregates may be too long. Some of the aggregates may be flaky. Some of the aggregates may be angular. Some of the aggregates may be round in shape. So actually shape and the surface, actually it has got some effect on the performance of the concrete. Okay. And then it should have limited porosity. What happens, if the aggregate is porous, at that time it will absorb more amount of water, and it will absorb also more amount of actually cement in the form of liquid. Actually, it will absorb more, it will require more amount of cement. And actually, the water that you use in the concrete, so that water is required, okay, to make a paste, to make a bond, and then between the concrete and the between the aggregate and the cement. Now, if the aggregate is porous, so actually some of the water will be absorbed in the pores of the aggregates, and at that time you will not have enough water to make the bond or to make the chemical reaction between the cement and the aggregate, to make the bond between the cement and aggregate. Okay. Desirable properties of aggregates. We define properties. Properties means certain characteristics of aggregates. Okay. So aggregates should be resistant to crashing. So you have one sessional. I don't know that this sessional has started or not, engineering material, and you have sessional in solid mechanics lab and concrete lab. Okay. And then in level 4, you will have some tests on aggregate, especially the crashing test, impact test, abrasion test. Okay, so this test you'll be doing in level 4. For now, you know that when the aggregates are used in the concrete, so that concrete may be used in a building, and then that concrete may be used in the pavement. In case of road, there are 2 types of pavement. One is rigid pavement and another one is flexible pavement. So rigid pavement, flexible pavement means the typical black top road that you see, that is a flexible pavement. And that also you use aggregate, but we also use aggregate in the runway. You will see that the runway is made of concrete. Okay. So whatever the aggregates are used in the concrete, and then it will be subjected to crushing load, then it will be subjected to abrasion, especially the aggregates which are used in the road, in the pavement, and those will be subjected to abrasion. And also during the whole lifetime of aggregate. For example, the stones, the moment it is crushed and then it is stocked somewhere, then it is loaded in the truck, then it is being carried, then it is again placed to the working site, then it is placed in the concrete mixture machine, and then ultimately it is placed on the road surface. So at every moment there will be some abrasion. That means there will be some wear and tear of aggregates. So aggregate should be such, the stone chip should be such, so that it can resist that abrasion. Sometimes aggregates will be subjected to impact load, so it should be able to resist the impact load. Okay, they should be of good shape matters. And then in case of water absorption, aggregate should absorb less amount of water. Why? What happens if aggregate absorbs more amount of water? We'll see that. Aggregate should be resistant to weathering. That means weathering means what? Due to the action of air, water, or temperature. So aggregates will be deteriorated. So aggregate should be such so that it resists weathering and that will make it durable. The good adhesion. So aggregate actually either it will be used with cement, or in case of flexible pavement, aggregate will be, the stones will be used with bitumen. So bitumen and cement are cementing materials. So aggregate should be such so that actually the cement or the bitumen can make bond with the aggregate. That is called adhesion. Surface texture. The surface of the aggregate, whether it is smooth or it is rough, that is important. Porosity, I discussed already. If aggregate is porous, that means it will absorb more amount of water or more amount of bitumen or more amount of cement. And surface chemistry of the aggregate. Some of the aggregates actually electropositively charged. Some of the aggregates are electronegatively charged. Okay, and then with aggregate, when you use bitumen, in case of highway construction, so there are bitumens for example, there are various types of bitumen, normal paving grade bitumen, then cutback asphalt or cutback bitumen, or emulsified asphalt. In case of emulsified asphalt, so there are cationic asphalt or anionic asphalt. So those cationic asphalt or anionic asphalt, so they will react with the electrically positively charged aggregate or negatively charged aggregate. So surface chemistry matters. So actually, desirable properties of aggregates, these are the 10 desirable properties of aggregate. To be more specific, we'll be now talking about the physical properties of aggregates. These are important for your exam also. Okay, so we'll be going one by one. First one is unit weight and void, in a specific gravity, particle shape and surface texture, and shrinkage of aggregates, absorption and surface moisture, and resistance to freezing and thawing. So what is actually unit weight? That means unit mass or bulk density. That means the weight of the aggregate, which is required to fill a container of a specified unit volume. So this is the container. Here you will place the aggregate. The container has got a volume. Okay. So and then the weight of the aggregate, which is required to fill a unit volume. So that is called the unit weight. And actually, when you fill this container with aggregate, so volume is occupied by both aggregate and also the void. Okay, because there are voids between the aggregate particles, and this depends on the this void depends on the size distribution of the aggregate. So the aggregates are of big size or smaller sizes, the shape of the aggregate particles, and how densely the aggregate is packed. Now, okay, and because if you put the aggregates in a container and if you shake the container, so it will become more dense actually. And then if you go for compaction, then it will become more dense. So actually, this is the issue which affects the aggregates unit weight. The two terms, one is loose bulk density and one is rodded or compact bulk density. When you put the aggregate as it is in a container, and then the density that you get, that is called the loose bulk density. When you put the aggregate in a container, and then when it is subjected to rodding, that means you compact the aggregate by dropping a hammer or dropping a rod of a specific size from a height, okay? So or a hammer from a specific height, so that will be compaction. That is called that will be called the rodded compacted bulk density. Normally, in case of normal weight aggregate, the bulk density of aggregate is approximately 75 to 110 pounds per cubic feet. So this slide you need not to memorize, just see this slide. Okay, there are various types of aggregate in terms of weight, and there are some examples of these aggregates, and in case of concrete, and how these aggregates are used. One aggregate is called ultra lightweight. So actually these are the minerals. That is the vermiculite or ceramic. So they fall under ultra lightweight. Okay, in the next slide we'll see the picture of the vermiculite. And then where this vermiculite is used, vermiculite can be sawed. Sawed means it can be cut, or it can be sliced, or it can be nailed. That means it can be attached or secured, okay, to some wall. And normally the main purpose of using ultra lightweight aggregate is for insulating purpose, because ultra lightweight aggregate has got some insulating properties. We'll see that in this slide. Then comes the lightweight aggregate. So these are called expanded clay. What is expanded clay? We'll see the next slide. Then shale or slate. We'll see the example. Next slide. And crushed brick. Crushed brick is a lightweight aggregate. So they are used primarily for making lightweight concrete. Concrete may be heavyweight concrete, lightweight concrete. Lightweight concrete structures, and also for in some cases for insulating purpose, lightweight aggregates are used. And the concrete that you normally see, that is made of normal weight aggregate. So there you used cast limestone and sand as a fine material. then gravel, or cast recycled concrete, and these are used for normal concrete projects. Another one is the heavyweight concrete. Actually, these are not the stone chips. These are the steel or iron shot, small balls, or steel or iron pellets. Actually, they are used for a special purpose for making high density concrete for shielding against nuclear radiation. So if you want to make a room where the wall will be of made of heavyweight concrete, there instead of normal stone chips with the cement, okay, you will use steel balls, okay, or the iron shot, and that will give shielding against nuclear radiation. Okay, so normally what do you see that normally in places where the radioactive materials are placed. So you want that radioactive materials actually they actually radiate, okay, towards harmful radiation. So if you want to confine it to the room, at that time the design of the room should be such, should be made of the heavyweight aggregates. I said that we'll see what is vermiculite. Vermiculite is a mineral. It looks like this. So it has got low thermal conductivity and low moisture content. And low thermal conductivity means that it does not allow heat to flow. Then it has got low moisture, and then it has got acoustic insulating properties. That means it prevents the sound to travel from one place to another place. That's why vermiculite, which is lighted aggregate, is used for the insulating purpose. We talked about expanded clay. So this is the machine or apparatus. What is expanded clay? It is a lightweight aggregate. It is made by heating clay to around 1200 degrees centigrade. Huge. And then as a result, there will be gases, and the gas will expand the clay by making small bubbles, okay, which is actually during the heating process. And then the resulting bubble will be the structure that it will have a honeycomb structure. So these are called expanded clay. So expanded clay is a lightweight aggregate. And vermiculite is a ultra lightweight aggregate. And they're used for insulating purpose mainly. We talked about shale. This is the sedimentary rock. And then slate. This is the metamorphic rock, which is formed from the shale over the period of time, so a process. So these are the types of aggregate. In terms of density classification of concrete aggregates, so if we talk about other lightweight, or structural lightweight, or normal or heavy aggregate, you need not to memorize this slide. Just see that the unit weight. We talked about the unit weight, okay? Weight of aggregate per unit of volume, isn't it? This was the unit weight. So unit weight of dry, rotted aggregate. That means the aggregate is dried. There is no moisture. So, and then it is compacted. So the rotting, okay? So in case of our light aggregate, its weight, unit weight will be less than 500 kg per meter cube. But in case of a structural lighted aggregate, so its unit weight will be more. It will be less than 2100 kg per meter cube. And this is about aggregate. And then this aggregate with cement and sand, can of water, which will make concrete. So in case of concrete also, the weight will vary. Okay. Then strength, and accordingly, strength will also vary. So in case of lightweight aggregate, where the strength is 17 to 35 MPa, megapascal. But in case of structural lightweight aggregate, okay, which is heavier, there will have more actually the strength, 20 to 40 MPa. And typical application is that ultra lightweight are used for non-structural element. The lightweight aggregates are used for insulating materials, and the structural lightweight aggregate and the normal weight aggregate that are used for normal concrete that we use. Okay, and heavyweight concrete we discussed earlier. It is used for radiation shielding. Voids. We talked about unit weight and void. What is void? Void means what? The empty spaces. So void content affects the mortar requirements in mixed design. What is mortar? The paste of cement sand, and water. That is called the mortar. So if the void is more between the aggregate particles or inside the aggregate, so it will require more amount of water and more amount of water. Okay. Okay. And the second one is that actually the void content. So it increase when if the aggregate is angular in nature. If the aggregate is rounded in nature, it will have less amount of void and it will become less amount of cement paste. Now, if the aggregate is angular in nature, that means there will be more amount of void. So in case of coarse aggregate, so void content ranges from 3 to 45%. And in case of fine aggregate, the void is 40 to 50%. And total volume of voids can be reduced by using a collection of aggregate sizes. For example, you use coarse aggregate, fine aggregate, and mineral fillers. That means if you use various sized aggregates and if you combine it together, so at that time what happens? The smaller aggregates occupies the space between the larger size aggregates, and then large aggregates occupy the space between the more large aggregates, and that's how you can reduce the volume of void, but it will increase the unit weight of the aggregate. See this example, okay? Here, actually, this container, it has got 1 inch size aggregate. This container, it has got 3/8 size aggregate. That means what? It is smaller in size. And then in this container, actually, you have combined these two, this 1 inch aggregate and 3/8 inch aggregate. So what happens? These smaller aggregates are occupying the voids between these larger aggregates. So this is represented by these 3 jar or beaker. Okay. So here you see. So the void that you have here with 1 inch aggregate, these are represented by water, as if the voids, that means the empty spaces, are represented by this amount of water. The voids actually that you can see with 3/8 size aggregate, this is represented by this amount of water. If you combine these two, as you can see in this slide, there is no change of volume, but because the smaller particles are occupying a space with larger particles, and as a result, what will happen? The void will come down. So the water is coming down means void content is coming down. So as a result, the cement paste requirement for concrete is proportional to the void content of the combined aggregate. In case of combined aggregate, actually, you'll be requiring less amount of cement paste. The next important property is specific gravity. So there are 2 types of specific gravity. Okay, what is specific gravity? This is very common. You learned it maybe class 10 or class 9. This is the ratio of the weight of an object to the weight of an equal volume of water at a standard temperature and pressure. So ratio of the sand or ratio of the aggregate to equal volume of water. So that will give you a specific gravity. So specific gravity is a dimensionless, okay, entity. And why do you use a specific gravity aggregate? Because it has a number of applications which will be coming later. Because in case of mix design, when you design a concrete mix, okay, which will be taught to you by Lieutenant Farooq in his part, that you will see that the value of specific gravity is used. Okay, then sometimes the specific gravity, lower specific gravity will indicate that the aggregates contain the deleterious particle. Okay, so to identify whether some aggregate has got deleterious particles or not, so specific gravity is an indicator. And also sometimes you will find that the aggregates that you have ordered from some source, and then when the aggregate arrives at your working place, so at the source you have identified the specific gravity, and at the site or working site, again, if you measure specific gravity, so if you find a change between the specific gravity, then you will understand that the supplier did not give you the aggregate that you have chosen, or due to various reasons like during carrying or due to the storage, okay, the material property changes. So if there is any change in specific gravity, so that is also an indication of material property change. Then comes the bulk specific gravity. Bulk specific gravity. is the ratio of the mass of unit volume of aggregate with, and it includes the water permeable parts and to at some specific temperature to equal volume of water. This is called bulk specific gravity. And in case of apparent specific gravity, actually for the material, in bulk specific gravity, actually it includes the water permeable parts. In apparent specific gravity, the impermeable portion of aggregate. That means the aggregate does not include the permeable pores in aggregate. So that is called the apparent specific gravity. Then particle shape and surface texture. So if the aggregate is rough textured, angular, and elongated. Elongated means it's longer in shape. Okay, it will be requiring more water to produce workable concrete. And then if the aggregate is smooth, rounded, and compact. So aggregate should be relatively free from flat and elongated particles. So some in the specifications, okay, of various organizations, you will find this limit. For example, in a specification, it will be mentioned that aggregates should not have more than 15% by weight of flat and elongated particles. And actually, this property, this particle shape and surface texture is important, okay, for coarse and cast fine aggregates because they require more amount of water and ultimately it will affect the strength of the concrete if the cement water ratio is not maintained. Because if there are more void, so you can maintain the cement water ratio. You have to maintain the cement water ratio when you make the concrete. Particle shape. We talked about particle shape and surface texture. In particle shape, actually there is one term called sphericity. It is a measure of how a spherical or round an object is. So it is defined as a ratio of the surface area of the particle to its volume. So high ratio of surface area to volume, that means it will indicate that increase the water demand for a given workability of the concrete mix. What is workability? Workability means how easily the concrete can be mixed. Okay, so if you have a surface area, high ratio of surface area, that means it will require more amount of water to get a concrete mix which is workable. Particle surface, it can be smooth and it can be rough. That is called surface texture. Texture is the feel. Okay, so the aggregate surface can be smooth or rough. So smooth surface is easy to work with that, and then rougher surface. Okay, but rougher surface, it has got one advantage is that the resulting bond will be stronger. Okay, than the aggregates which are smooth. But because smooth aggregates, they will not make strong bond between them. But rough surface aggregate, though they are actually less workable, okay, less easy to work with, but ultimately they will make better bond. Then shrinkage of aggregates, large shrinkage and low shrinkage. There are some aggregates like sandstone, slate, basalt, trap rock. So they shrink more. And there are some aggregates like quartz, limestone, feldspar, or the granite. So they have got low shrinkage. Actually, what happens if abnormal aggregate shrinkage occurs? No, actually, if the shrinkage means the change in volume, that means contraction of aggregate. So at that time, what will happen? There will be crack, okay, in the resulting concrete. And then in case of beam, and in the long term, okay, there will be other reasons, but in beams and slabs, you will see deflection. And then sometimes you can see in some of the buildings, you can see that the concrete is coming out of the structures. That is called spalling or chipping or crumbling. So if the shrinkage percentage is more than 0.08, so the aggregate will be considered as unreliable. Okay, so that's how shrinkage is important. Problems of shrinkage, we are discussing about that issue. The absorption and surface textures. If water content of the concrete mixture is not kept constant, okay, for example, you are mixing aggregate with cement and water, okay, and then one mixture is prepared, then you have taken it to some site, Okay, and then you have taken it to some site. Okay, so from batch to batch, if the water content varies, so the strength, workability, and other properties of the aggregates will vary from batch to batch. So actually here I finished today's class. Okay, now you have 5 minutes break and you join the class of Colonel Funk. Okay, thank you. You can leave my class. Islam.